Very good morning, sir. I, Sukri Sarna, on behalf of our group, is going to present you all with the visitor management system. That is our today's agenda or this term project for us, which has been hosted on the AWS software. Moving forward to the introduction of our particular project, a visitor management system tracks the users of a business, public building, as well as the site on which it has been deployed. It ensures proactivity, that is getting information of who is assessing the facilities. It integrates the communication, risk management, and incident management systems, as well as reduce the cost of the previous pen paper visitor management, as well as effectively enhances the surveillance as well as the staff communication throughout the system as well as throughout the facility. Moving forward, as talking about the use case diagram of our current project, as you can see in the slide shown above, the user has given two options. First is the check-in option and second is the checkout option. While pressing at the and going towards the check-in feature, he has to fill in the required details that are the basic nominal details like name, phone number, email address, etc. After filling all the details, he get two options. One is the submit command as well as second is the go back command. After clicking on the submit command, he actually logs himself into the system. This particular system has an additional extension, that is the already check-in feature, that if for example the person clicks on the submit button and he has already been added as the person, he will already get back to redirected to the check-in home screen. Moving forward, if the person go towards the checkout option, he has to fill in the almost same nominal details, and then he also get two options, submit as well as go back command, which act at the same. The going towards what the admin has seen is that the admin can go and see all those person who are being logged in into the system, as well as he also get an option of clearing all the logs. Moving forward to the corner cases, if a person has already been checked in, he cannot check in again until or unless he has checked out from the system. A visitor who has been checked in from a given ID cannot check out from a different ID, as well as a person who is already been checked out cannot check out himself again without check in first. So these are the corner cases. Now I would like to call Amitesh to move forward with the tech stack of our project. Over to you, Amitesh.
So basically, the tech stack used here is being segmented into three parts: the front end, back end, and the AWS services. So basically, front end consists of the framework being used as Bootstrap and HTML and CSS, and EJS being used, which is the embedded JavaScript. It is generally being used to use JavaScript with HTML and CSS inline. And in backend, we have used Node.js and Express.js. So Node.js is basically the open source runtime environment which is used to like run JavaScript outside of the web browsers or in the backend. And the AWS services used are EC2, DynamoDB, SNS, load balancer, VPC, and CloudWatch. So the advantages of using AWS are as follows. So the first one is it is very easy to use, as AWS is designed to allow application provider or ICV or vendors to quickly and securely host their applications with an existing software as a service-based application. And the second one is flexibility. So AWS enables you to select the operating system, programming language, web applications, and database and other services to be flexible with multiple platforms so that they could be run effectively. This next is cost efficiency. So basically, you only pay for only the computing power, storage, and resources that you are basically using, and there is no long-term contracts with them. And the next is reliability. So with AWS, you can take advantages of scalability, reliability, secure global computing infrastructure, and other virtual platforms, which is very reliable these days. The next is scalability and high performance. So basically, using AWS tools and auto scaling and elastic load balancer, your application can basically scale up or scale down as per the demand of the user. And the last one is security. So basically, AWS utilizes the end-to-end approach, which is basically very secure and that infrastructure help us in operating, balancing the software measures very easily and effectively. So now next to Khush would tell you about the AWS services.
Myself, Kush Chaudhary, I will firstly talking about Amazon EC2 services. The EC2 provides us a scalable computing capacity and in the Amazon Web Service cloud architecture. Its main advantage is that it gives us auto scaling. In auto scaling, we need to worry about scaling manually as we can just create multiple groups and then Amazon AWS will handle the scaling portion. It also follows a pay-as-you-go model and it also has a built-in security options. Now moving to Amazon SNS, it is a simple notification service which provides us message delivery for our application, that is our entry management system. Main advantages of Amazon SNS are that it has an instantaneous push-based delivery. It also has a simple API, so it was very easy to use. It also follows same pay-as-you-go model. The next services that we use was CloudWatch. It is the Amazon's monitoring tool for EC2 and its other instances. The main feature that we use here was that it has a thresholding option, so we can stop our underutilized instances. Next, I would like to call on Pulkit to further explain about DynamoDB.
My name is Pulkit, and my part is the database design using DynamoDB. So, DynamoDB is a NoSQL database service. It allows you to create full backups of your table for long-term retention and archival for regulatory compliance needs. And it also spreads the data in traffic and balances the table's data over a sufficient number of servers to handle our throughput efficiently and maintaining our storage requirements as well to maintain the database and keep it consistent and to keep it fast as well. Next, I will tell why we preferred NoSQL database over a relational database management system. So a NoSQL database can store unstructured, semi-structured, or structured data as well. So overall, it is more flexible than relational database. This also helped us in our project because our project needed some flexibility because sometimes we needed to add some data afterwards. Uh, and in relational database, we need to pre-design the table already, and we cannot, and it is very difficult to edit afterward. So relational database has a con over here, and NoSQL has an edge over relational database. So this was preferred. And another main point is that NoSQL is developer friendly. Uh, Nowadays, every developer must know that all the websites communicate with each other in either JSON or XML format, and JSON format is even more popular than XML nowadays. So data in a NoSQL database is stored in similar fashion to JSON objects. So this makes it easier to use with code as well. Now I will explain the database design. So the collections I made was three collections, namely client, host, and visits. And as you can see, client store name, email, phone, and address of the client. Host similarly host details, and the visit will store the email ID, check-in and check-out, and host email ID. So I created three collections for the database part. Now, why did I create three collections? So this was to reduce redundancy in our database, and this to reducing redundancy is also called normalization. So had I been if I had created only a single table, then there would have been more redundancy because we have to store the data again and again. If the same user checks in again, so we have to store the new data again uh, in a new tuple. So this would increase the data storage, and it would not be good for the space complexity of our database. So dividing the table into three collections had reduced the redundancy because we have linked the clients and host table to a single table visit. So client and host, if they are visiting again and again, their details will be stored only once. Now over to my friend Shivam, who will explain the rest of it.
Hello, I am Shivam Sharma, and I would be explaining about the data flow and infrastructure of the project. So first, what the user does is he would type in the URL in the browser, and then when he presses enter, get request is sent. which is directed to the load balancer by route 53, which essentially acts as a DNS server. Okay, so then the request is then sent to an EC2 server, which has enough resources to generate a response. So the EC2 instance runs in an auto scaling group, which provides high availability and also easy management. So the user receives the response, fills in the required information, and then sends a post request. Moving forward, next slide, please. Okay, so now the post request is also directed in the same manner by Route 53 to the load balancer and then sent to an EC2 server. So now the data entered by the user is processed by EC2 and then stored in DynamoDB. The EC2 server also sends a request to SNS simultaneously, which in turn pushes an email and an SMS to the host. Next slide. So this figure shows the complete infrastructure of the software. All of this is hosted under AWS VPC. It lets us provide kind of an isolated section of the AWS cloud where we can launch AWS resources in the virtual network that we have defined. So there are generally two kinds of subnet in VPC. One is a public one and the other is a private subnet. So in the public one, we deploy the resources that we want to make public. Like in the software, it would be the classic load balancer since all the requests are directed through it. If there were no load balancer, then we would have to put the EC2 instance in the public subnet. So in the private subnet, we would deploy the resources we don't want outsiders to have access to. Like here, we would put the EC2 auto scaling group and a database, DynamoDB, in the private subnet since it will be accessed by our application only. Also, if the private subnet instances want to access the internet, they can do that using NAT gateway in the public subnet. So here we also have CloudWatch, which collects monitoring data in the form of logs, metrics, and all from EC2 and DynamoDB. If there is any abnormal behavior, we would be able to detect it using CloudWatch and can set alarms and automated actions. This helps us to keep the application run smoothly. So now over to Himanshu, who would be explaining the demo of the project.
Hello, welcome everyone, and greetings for the day. My name is Himanshu Mishra, and I will be showing you a demo of our project. So here we are in the AWS console, and we can see these are multiple servers in AWS instances. So basically, what we did initially is created a base server in which we deployed our app. So why we needed that base server is because initially we had to build everything from scratch. So we deployed our app on it, and then AWS provides us with us a service of AMI. So what we can do is basically create an image of this our base server and use that image to create multiple different servers. And those other servers will be a complete copy of this our base server. So what we did is used our base server, deployed our app in it, and then created an image of it. And why we needed this image is because we needed a complete setup of what we did earlier in our base server. So next, we use launch configuration. So what is launch configuration? Basically, in an auto scaling group, what auto scaling group does is initiates multiple servers when the request starts coming in. So let's say we have a website and multiple requests are coming in. So let's say our single server is not able to handle those requests. So what auto scaling group does is it is going to initialize more servers for the website. So there are particular guidelines, particular rules that we need to provide our auto scaling group. And according to those rules, it will follow those rules. And according to those rules, it is going to initiate other servers. So in launch configuration, we specify these rules. So and we have to use our Amazon machine images in this launch configuration in order to tell auto scaling group what is our app and what type of details and configurations we need in our servers. So initially we have created our two different auto scaling groups, and currently these auto scaling groups are running only single servers, and its maximum capacity has been set to two multiple servers. So if we increase the load on these servers, what will happen is it is going to initiate another server for us, and we don't need to handle that initialization and setup of a new server again and again. But in autoscaling group, there is no load balancing. I mean, it is going to create multiple servers at a later stage. But what's if new requests are coming in, there is nothing that tells our autoscaling group that where those requests needs to go. So let's say an autoscaling group launches two servers. So if multiple requests are coming in, it is possible that only one server is getting heavy load and another server is getting lesser amount of load. So for this, we had to use our load balancer. So what we did in our load balancer is we created a load balancer and attached our two auto-scaling groups to this single load balancer. Now what this load balancer is going to do is it is going to take the incoming requests and it is going initially divide the number of requests over two auto-scaling groups, and it is going to first do health checkups and learn how many servers are there, and it is going to divide equally our load on these our EC2 instances. Uh, the load balancer also provides us with different kinds of services, such as it is going to give us an option. How can we divide this incoming traffic? So either we can divide it equally, or we can also set up some another set of rules which divides it separately to one type of traffic to one server and another type of traffic to another server. So here, if we go to our or load balancers website, so this is our website, this is our complete app. So what we did is basically use the DNS name for our load balancer and put it in our browser. So what it did is actually send the request to one of our servers. So let me go through this and show you how our app works. So basically what in this management system we are doing is checking in and checking out. And here we have also a data log that is visible to us, and it is this database is hosted in DynamoDB. And in order to show that whether this worked or not, here we have our monitoring graphs. In this, we can clearly see the last one is the request that I currently did, and these previous dots are representing the requests that I did in testing phase. And also, if we go to our one of the EC2 instance, here we can see it is providing us our all the data, all the monitoring with our CPU utilization to network bytes and packets that are incoming and outgoing. So next, Sukrit is going to conclude our presentation. Over to you, Sukrit.
Um, while heading towards the end of our presentation, I would like to conclude by saying that this project demonstrates the pros of using a cloud platform like AWS for deploying of the web application, as we have seen the visitor management system. It is highly available and cost effective since it is deployed on a cloud platform that is pay as you go service. We have also learned new skills while developing this project. We try to participate and practice the various proper software development guidance, as well as everyone from our group has contributed to the development of this project. So through this, I would like to thank you, Anime sir, for providing with such a good topic, as well as this is where we are ending today's presentation. Thank you so much for listening. Thank you. Cut.